My name is Seung Pil Bang from South Korea, and I'm a clinician ophthalmologist and also a vision scientist who is working for testing these IOLs and then how it research about how it works about it. So today I'm gonna talk about the optical characteristics of Hanita Intensity IOL, which is kind of optical secrets because it's really interesting design. So let's move on. So this is kind of a summary slide which can show the novelty of the intensity IOL. Number one, sinusoidal. Number two, dynamic light utilization. And number three, GS algorithm. So let's deep dive into it. Okay, number one, sinusoidal diffractive design. So let's review about the conventional diffractive trifocal design. So as you can see on the top left, you can see that the monofocal diffractive can be designed as with the lambda jumps, and then on the bottom you can see the bifocal diffractive, which has a half lambda jumps, and then these two are really easiest way to make monofocal and bifocal diffractive designs. And then if you summate these two designs, and then you can see on the right the trifocal diffractive lens. So here is how we can design the trifocal. And then if you see these wavy sawtooth profile, definitely you can see these are what we call kinoform, which means in Greek the movement and the form. So which can also show that this is a wavy movement diffractive designs. Okay, so let's review one more time with the diffractive design. So on the left, here is a kind of example of a conventional kinoform design, which is a panoptics, and then on the bottom it is intensity. So as you can see, kinoform is much more sharper in edges, and then sinusoidal is much more smoother, and then it looks like more like a sine wave. That's why we call it sinusoidal. And then this is a kind of new classification if we talk about these diffractive designs. And what is the difference? So on the left, the kinoform has some disadvantages, such as a scattering from the edges. Diffraction efficiency is less than 90%, and it is also hard to manufacture. But with the sinusoidal designs, it's less scattering, has a diffraction efficiency larger than 90%, and it is relatively easier to manufacture, which is a huge advantage. So with this kinoform diffractive design, theoretically, the maximum diffraction efficiency is 84.3% with the trifocal design, and then 88.5% with the quadrifocal design, which is well known with the panoptics, right? But with the sinusoidal diffractive, theoretically, again, the maximum diffraction efficiency is 92.5%, which is a little bit less than the Hanita intensity. Interestingly, Hanita intensity has a 93.5% efficiency, which has a less light loss. One more thing, yes, manufacturability. So as you can see, their capability using this single point diamond turning technology, and then with this diamond cut, they can make a very smooth profile and then easy to manufacture, so that there's less and then reduce errors and deviations in their manufacturing process. Okay, let's move on to the second one, the dynamic light utilization. This terminology is actually not from me, it's from the company, but I want to highlight this terminology is to show the zone segmentation for the pupil optimization. So as you can see, there is 3 zones, right? Zone 1, Zone 2, Zone 3, and then Zone 1 is up to 1.25 millimeter, Zone 2 is up to 2 millimeter, and then Zone 3 is about 3 millimeter pupil irradiance. And if you see closely, and then you can see now that Zone 1, right? They put more weight on the near vision with the wider edge on the top, and then with the Zone 2 and 3, there is a little more energy to the far and intermediate compared to the Zone 1. So in fact, this design mimics the physiological pupil dependency in that the pupil gets smaller and the lens power increases by accommodation, so it is all for the near vision. So now you can see that with the increase in the pupil diameter, So light energy goes more into the far focus, which is similar to the apodization design. So it can give the patients less photic phenomenon with the larger pupils when they drive at night. Okay, the last thing is GS algorithm. So I want to say this is for phase optimization, and so let's look into more closely. So GS algorithm, I know this is a little bit hard concept for clinicians to understand, but in real simple words, I would like to say this algorithm is an iteration process so that you can achieve your targeted energy distribution. So let's look at the example. On the left side, there's a one sinusoidal profile on the top, and then if we do the Fourier transform, and then on the right, you can see there is a diffraction efficiency with the diffraction orders. And then this one has a uniform, three different uniform diffraction efficiency with different foci. But now, if you want to highlight more for the far focus, and then you should change its distribution, right? And then once you set up this distribution, and then you can do the inverse Fourier transform to get the new phase profile. That's how the intensity come up with this GS algorithm to optimize this energy distribution. So once again, the zone 1 is a good example. So zone 1 has a unique shape adjustment and also a little bit height adjustment so that it can have more energy for the near distance. So here are IOL bench test results, what I have done with this Intensity IOL. You can see that with these microscopic images, the Odyssey and Synergy is more prominent than the Intensity, so which means they have a higher step heights compared to the Intensity, and then it can also induce more forward scattering as well compared to the Intensity. I did the IOL bench testing with the Nemo Tempo, one of the well-validated IOL bench testing, and what I've got is I could find the Intensity did not have a significant spherical aberrations compared to the Odyssey and Synergy, which means Intensity is a purely diffractive multifocal with less spherical aberration in the IOL design. So if you see the real diffractive step profile with this Nemo Tempo, you can see that the Intensity has a real sinusoidal design compared to other kinoform designs with this bench testing. And also with the through focus MTF curve, you can see that this 3mm pupil size result is exactly same as what the company provides. So their design is, I want to say, is reliable. Let's look more closely with each MTF curves with the different pupil sizes. So with the 2mm pupil size, Intensity is more near dominant, which agrees with their intention with the zone 1 segmentation. And with the 3mm pupil size, it is now far dominant, but also well distributed energy with intermediate near, which agrees with the zone 1 plus 2 segmentation combination. And if you go up to 4.5mm, it maintains far dominance with the intended zone segmentation, so it includes now zone 3. So it all matches with the MTF, through focus MTF curves. I want to introduce one more aspect with this IOL, longitudinal chromatic aberration. So as you may know, our eye has its own longitudinal chromatic aberration, makes red light focus behind the retina and the blue light in front of the retina by this dispersion. But with certain design of diffractive IOL, we can correct this LCA so that all of the wavefront, all of the wavelengths can focus on the same retinal plane. However, there's one condition if you want to achieve this goal. So in the equation on the top, you can see the letter M, which shows the diffraction order. So if this diffraction order is positive, then you can correct this LCA. But what if it is negative? Then LCA can be increased. So it is opposite. So with the conventional kinoform IOL, right? So they have a negative diffraction order usually. There's no negative diffraction order. They usually have a positive diffraction order. So which means it can correct the LCA or not. But sinusoidal, you can see, for example, intensity has a negative refraction order -2 for far. So, which means it can increase the LCA for far focus. Okay, what happened? So theoretically speaking, compared to the monochromatic light with the white light on the right, okay, MTF is a little bit going down for far focus as you can see on the right, which may affect the visual acuity for far vision. But does it really matter in real world? I would like to say the answer is no, because always monochromatic aberration is more dominant compared to the chromatic aberration, and also our brain, our neural system is already adapted to our own chromatic aberration. And another reason is our retina is less sensitive to the red and blue light, so chromatic aberration does not affect really much in real world. So then, which situation we should care about with this IOL? I think there can be very rare situations like this, like professional shooters or motorcycle riders who use the red goggle so that they have some kind of monochromatic situations. So you may think, okay, maybe it is better to suggest them to avoid these kind of monochromatic situations. Or for night drivers, they can see this rainbow halo and glare, which is not that significant. Here's one more interesting finding from the surgery. So if you put this IOL, and then let's see, here, so one more time. It's quite quick, but there's a unique feature. So there is some halo when you put this IOL, like rainbow halo. So this is kind of a very unique feature of this IOL. Okay, so this is my last slide for today's presentation. Can we trust the post-op AR results with this IOL? There is one good previous paper showing that this IOL give you a significant amount of myopic result with the AR, with this Intensity IOL, almost about 1.2 diopters compared to the MR result. Why is that? Because Intensity has a very unique sinusoidal design. So if you use the AR with the near IR light source and all energy now, as you can see on the figure, the red line, all energy with this specific wavelength goes into zero diffraction order, the intermediate focus. So this is why it can induce a significant amount of a myopic shift with the AR, with this near IR light source. So one more caveat is that if you want to check you should check your own AR device for the wavelength, and also you should think about patient's pupil size if you want to use your own AR results with this IOL implantation. So here is the take-home message. So Intensity is a very unique design, interesting sinusoidal diffractive design, and these designs have many advantages such as less light scatter, superior diffraction efficiency, and easier manufacturability. So please keep in mind there should be a LCA effect, which is pretty minor, but also your AR result is not always reliable. Thank you for listening. Any questions? No? Oh yeah, please.
The AR is always unpredictable with the multifocal lenses or even with the add-off lenses. So how you tell exactly what is the post-operative refraction with this bias?
Thank you for a very good question. So, especially this design, there is a kind of trend, as you can see over here, the myopic shift with a certain amount. And with other designs, let's say panoptics or other multifocal designs, usually they use a zero diffraction order, which means if you use the IR light source with the same device, it all goes to the zero diffraction again. So which means it is okay to use because zero order didn't induce any chromatic aberration anymore. So you can just trust your AR usually with the conventional diffractive designs. But this one, as I told you about the chromatic aberration, if you think about the chromatic aberration, it affects the AR results. So it is very unique compared to other designs.
Thank you very much for your nice talk. Yeah, I have one question to you. In case of the refractive type EDOF IOLs, how about using the AR as its target?
Very good question again. So if you think about the principle of EDOF lenses, there should be a lot of aberrations, especially the Spurker aberration. And the Spurker aberration can induce a power profile with the pupil dependency, which means it always changing with the patient's pupil size. So if it is smaller than usual, then you are gonna get higher power from the AR. If the pupil size is larger, which means it is going a little bit, same as what you are expected. Yeah, thank you. Thank you very much for everyone. Thank you.